Consider, for example, the businessman who says, profits rose. Profits rose. Now, you know, profits don't rise unless the safe blows up or something like this. What profits do is they increase or they decrease. The reason that we say profits rise is that when the profits are increasing, if we are plotting profit in terms of time, the resulting graph shows a rising tendency. As the profit increases, the curve rises. And in other words, then, we begin to establish the feeling that we can identify the analytic term increasing with the geometric term rising. And this identification, whereby difficult arithmetic concepts are visualized pictorially, is something that begins not only very early in the history of man, but very early in the development of the mathematics curriculum. Oh, as a case in point, consider the problem of 5 divided by 3 versus 6 divided by 3. I remember when I was in grade school that this particular problem always seemed more appealing to me than this problem. That 6 divided by 3 seemed natural, but 5 divided by 3 didn't. And the reason is that in terms of visualizing tally marks, it was much easier to see how you divide 6 tallies into 3 groups than 5 tallies into 3 groups. However, as soon as we pick length as our model, the idea is this: either one can divide a line into 3 parts of equal length, or one can't divide the line. Now, if I can geometrically divide this line into 3 equal parts, and in plane geometry we learn to do this, then the fact is that I can divide this line segment into 3 equal parts, regardless of how long this line happens to be. Oh, to be sure, if this line happens to be 6 units long, this point is named 2. And if, on the other hand, the line happens to be only 5 inches long, the resulting point is named 5/3. But notice that in either case, I can, in a very natural way, define or identify either ratio as a point on the line. And this idea of identifying numerical concepts called numbers with geometric concepts called points is a very old device, and a device that was used and still is used in the curriculum today under the name of the number line, under the name of graphs, and what we will use as a fundamental building block as our course develops. Now, you know, in the same way that we can think of a single number as being a point on a line, we can think of a pair of numbers, an ordered pair of numbers, as being a point in the plane. This is Descartes' geometry, which we can call coordinate geometry. The idea being that in the same way that we can locate a number along the x-axis, shall we say, we could have located a number pair as a point in the plane. Namely, 2, 3 would mean the point whose x-coordinate was 2 and whose y-coordinate was 3. By the way, the reason that we say ordered pairs is if you observe 2, 3 and 3, 2 happen to be different pairs. And notice again how vividly the geometric interpretation of this is. Namely, in terms of locating a point in space, it's obvious that the point named 2, 3 is not the same as the point named 3, 2.